starting on the first video here, I've started that you shouldn't use a calculator because you're not going to be able to use one on that test. And then hopping into number 1, we do a of 1 and wants us to evaluate it. So I am going to do a of 1 first. And you'll notice here, I changed the problem just to make it work out a little bit better. We're going to be doing it by hand. So I'm going to have 2 to the first power plus 1 to the third power, which is 2 plus 1, which is 3. And then that means I'm going to do a of 3. So I can replace a of 1 with 3. So I can do a of 1 is a of 3, which is 2 to the third plus 3 cubed, which is 8 plus 27, which is 35. And finding the inverse of b. Remember the steps. I'm going to switch, or I'm going to have to rewrite it as y first. So for b, I would rewrite it as y equals 3x minus 7. Then I'm going to switch x and y. Miswrote that ahead of myself. Then I'm going to solve for y. So x plus 7 equals 3y divided by 3 divided by 3. Now y is by itself. And then I can rewrite it in inverse notation. Oh, and notice here, I made the mistake myself. I didn't do it on purpose, honestly, but it's a really good point to make. So notice I'm doing b of x, so to write it in inverse notation, it would be b to the negative 1 of x equals. Okay, then for c, this one's a little bit more involved because I've got a rational function, x in the numerator and denominator, but let's work through it. So I've got, step by step here, I have, write it with y, and you're gonna switch it both places. So x equals 2y plus 3 over 8y minus 9. And then I'm gonna multiply both sides by 8y minus 9 to get out of the denominator. So, if I distribute here, I'm going to have 8xy minus 9x equals 2y plus 3. And remember, on this step, I need to get my y's together. So when I get my y's together here, I need to minus 2y here. And then I need to get everything that doesn't have a y in it. So this x here, I'm going to add 9x on both sides. And that gives me 8xy minus 2y equals, I've got 9x plus 3, okay? And then here, this one's a little bit confusing. It shouldn't be like this on the test, but you might be tempted to go ahead and factor out the 2, which by all means, like if I wanted to factor out 2y, I can. It would be correct. You're just gonna add steps to this though. That's part of the issue. So I'm trying to get y by itself, so all I'm gonna factor out is the y. All I'm gonna factor out is the y. Because what that allows me to do is just divide by this here. And then just rewrite it. Because now y is by itself. And I've got y equals 9x plus 3 over 8x minus 2. And I can rewrite it. I'm doing the inverse of c here. So I'm going to write it as c to the negative 1. X equals 9x plus 3 over 8x minus 2. So when I look at this, one helpful thing is because here I'm starting with a fraction with a with the numerator. With the variable in the numerator and the denominator. I've got x in the numerator, x in the denominator. My answer should have the same thing here: x in the numerator, x in the denominator. Let me erase that. We'll move on. Then we want to find the inverse of d. So let's rewrite that. Let's rewrite d with y. So y equals 8 to the x minus 9 plus 3. Yep. Okay, let me zoom in a fuzz. Let me draw this line to separate this out. So I've got, switch the variables. I'm going to minus 3 on both sides and get x minus 3 equals 8 to the y minus 9. And here's where the logs come in handy, because now I've got 8 as my base and y minus 9 trapped in the exponent, so the log is what frees it. I use the same base. The base here is 8, so I'm going to do log base 8 on both sides. These cancel out. I'm left with log base 8 of x minus 3 equals y minus 9. Add 9 to both sides. I'm left with log base 8 of x minus 3 plus 9 equals y, and rewrite that. This is d, so I'm going to rewrite it as d to the negative 1 for the inverse notation. So d to the negative 1 of x is going to be log base 8 of x minus 3 plus 9. Then go in here. We have the graph in the table below to answer the questions. The 5 wants us to do g of h of negative 2, which is not too bad. So I go to h of negative 2 first. So there's not an inverse, so it's just pretty straightforward. So h of negative 2 gives me 4. So h negative 2 gives me 4. And then when I do the whole thing, it's going to replace h of negative 2 with its value. So it wants me to do g of 4. G of 4 is right here, which is 2. And then for 5, I want to do h, the inverse of h, evaluated at negative 2 first. And remember, your x and y values flip. So when I'm doing h, like the inverse, I'm really looking at the y value on h. So my output is negative 2 when it's negative 3, so I've reversed the order. So the output there for the inverse is 3. And then I do g to the negative 1 of 3. And remember, I'm thinking of this as a y value as an inverse too. So I go over here, boom. The y value when y is 3, my x value is 5. Then for the domain and range of the inverse of g, so we'll do the domain. Remember, the domain and the inverse is going to be like, you flip the domain and range of g. So the domain of the inverse is going to be the range of g. So we'll write it in interval notation here. So the range of the original function on my graph here is from negative 4 to 3. Okay, so the domain of the inverse is going to be the range of the original function. Same thing the other way. The range of my inverse is going to be the domain of the original function. So from negative 5 to 5, that is going to be my new range. And then for the max and min of the inverse, it's going to, when it talks about the max and min values, remember this is always talking about y values. So why that's important is it's the y values of my inverse, so that can come straight from my range. So my smallest part of my range, because remember, range is my smallest y value to my largest y value. So the smallest y value here, my minimum, is going to be at negative 5, and my maximum is going to be at 5. And what is my memory saying for logarithms? Logs are bay. And if I have this random logarithm here, like for the how does it work, log base 4 of x equals y. You label this as b for my base. Logs are bay. This is my a, and this is my e. So if I want to write it in exponent form, my base for my exponent is 4. My exponent is y, in exponential form, I should say. And then my argument moves to the other side and is x. Now switch each of the following forms. And once again, I'll label it for the first couple and then just go piece by piece. So let's do on this one. This is actually going to be a little bit confusing because some of the letters might match, but it's okay. So A is my base, E is my exponent, and C is my answer or argument. So logs are bay. So I start with my B value, which is A. My A value comes next, so log base A of my exponent, which is B. Sorry, got ahead of myself. A lot of letters there. It makes a lot more sense without the numbers, with numbers instead of letters, rather. So this is my base, exponent, and argument. So then logs are bay, so I start with B, then my argument, and then the other part, boom. And then to rewrite this one really quick, same thing. My base is swag. My argument would be nice plus eat, and equals to lit bay. And then here, we're in log form and we want to switch. So if we're already in log form, remember, if it's just log, the number here is always 10. That's like if it's just log by itself, there's understood to be a 10 there. Log base 10 of 12, x equals 13. And remember, labeling it is helpful. So bay, so 10 is my base, 13 is my exponent, and then my answer or argument is going to be 12x. Same thing here. X to the z equals y. And then it's a little bit more confusing to rewrite this in ln form, so I would always change ln to log base e first, because that's what ln represents, the natural log. And then e is my base, so e to the b equals negative 3x minus 5. Evaluate each of the expressions below. So remember, when you're doing these, I always set them equal to x to help you think about it. So using the powers of bay, that's a little cringy, but it works. Using the powers of bay, b, a, e. I can rewrite it. So 2 to what power equals 32. And if you don't, once again, this is where it's going to be a little bit tougher because you don't have a calculator. So you're going to need to work on this. If you don't naturally know it, you can just count 2 times 2 is 4. That's 2 times 2 is 8 times, and just counting on I'm counting on my fingers right now. I've got 3 up, times 2 again is 16. That's 4 times 2 again, that is 32, and that's 5. So evaluating this gives me 5. Same thing here. It's going to be 49 to what power equals 1/7. So one thing I see already is how would I flip 49 to the bottom? So I know one part is it has to be negative because it's flipped. So it's negative because it's flipped. And then I know the square root of 49 would give me 7. So it's going to be to the 1/2 power, negative 1/2. Okay, so let's go piece by piece. Let's plug it back in and make that make sense. So 49 to the negative 1/2 equals 1/7. So I can rewrite the negative by flipping it. So 1 over 49 to the 1/2 equals 1/7. And remember, taking something to the 1/2 power is the same thing as doing the square root. So basically, I'm saying the square root of 49 is 7, and that works out. And then in blue here, let me erase this actually for the answer key. I would always, once again, anytime I have these, I'm going to write it as log base e again. And then rewrite it with base, so e to the x equals e to the 9. The bases are the same, so the exponents have to be the same. That has to be 9. And then here, when I'm doing log base 8 of 2 equals x. So 8 to what power gives me 2. And basically, when you're getting smaller, like I'm going from 8 to 2, I'm usually going to have a 1 over something. Okay, I'm going to have 1 over something because it's what root? So is the square root of 8 2? No, but the cube root is, so it's going to be 1 over 3 because the cube root it is. And then make sure you pay attention to this part right here. The definition is going to be really important, and I'll show you what I mean here. So label each table as exponential or logarithmic. So for my input values, x is my input values, and my function a of x is my output values. These are plus 4, plus 4, plus 4. Okay, what's happening here? Times 3, times 3, times 3. So my input values, this is how my input values are going up by the same interval, and over the equal interval, I am multiplying by 3 every time. So I would say that this is exponential because output values are changing multiplicatively over equal length input values. Okay, and then this one's going to be the other way, so I'm multiplying by 2 on my input values, and I'm adding 2 on my output values. So this would be logarithmic because now it's the input values. It's the difference between the input and output values. So for exponential, the output values are changing multiplicatively, but now my input values are changing multiplicatively. I had to think about how to spell that for a second. It's a little bit of a longer word. So logarithmic because the input values are changing multiplicatively over equal interval output values.